What's up, people? Welcome to the session. I hope all of you guys are doing good and your loved ones are also doing good. You guys are staying home and staying safe. Welcome to the Prodigy sessions. Welcome to Vedantu 9th and 10th English channel. Once again, I hope that you guys have already subscribed to the channel because we have tons and tons of new content coming our way. And today we're going to be starting off with the very first chapter for Icse 10, that is for session number 1. So yeah, happy news, people. So today we'll talk about one of the basic concepts of force, that is stock and couple. What is the difference between them? What are the formulas that you must remember? And why is this so important? Let's talk about all of that and why is it used in our day-to-day life, or how is it used in our day-to-day life? All of that is what we're going to talk about. So before we get started, my name is Anoop. I'm a master teacher of physics here at Vedantu. Welcome back, and also do not forget to subscribe to the channel, hit the like button, hit the bell icon. What else is there? Do all of this and also share the video. Yes, so let's start with what is stock and couple. Now, before we get into that, guys, this is what you have. This is okay. We're going to start with a very simple quote and then we'll get into the topic, right? So the quote for today is this, guys: a goal without a plan is just a wish. Now all of you guys might want to get 90%, right? Make your parents proud, make yourself proud. Maybe you want to get 99%. Now that's your goal. But if you don't have a plan to achieve that, it's just going to remain a wish. You would have wished that you would have gotten 90%. So you have to have a plan, and then you have to take an action on that plan as well. Just making a timetable and making a plan will not help. You obviously have to take an action on it, and that's what makes all the difference. So with that said, let us begin this wonderful year. I know it's not a great year to start off, but yes, let's start off with one wonderful academic year with this wonderful quote. All right. So these are the topics that we have. So we have talk and couple, equilibrium and principle of moments, center of gravity, UCM, centripetal and centrifugal forces. All right. So all of these are the topics that we have. We're going to be doing one after the other. So let's get into what is torque and couple. All right. So let's start with a simple example, guys. Imagine you have a body, a rigid body. Let's say it's a brick or a piece of wood, whatever you want. Just go wild with your imagination. Now, let's say that you're applying force F1 and F2. In the first case, you're applying it at the middle. All right. Now, remember this box or this wooden box or whatever you want to call it is not fixed at any point. It's free to move about. All right. So you're applying a force at the middle. And in the second case, you're applying the force at two ends. All right. So a same amount of force, the magnitude of force remains the same, but the place that you're applying, or the point at which you're applying the force is actually different in the second case. Now, here's the thing, guys. When you talk about force, when you apply a force can cause about two types of motion. One is transitional motion or straight line motion. The other is rotational motion. And rotational motion is something which you can see when a body is fixed about an axis, when it's fixed, when any rigid body for that matter, when it's fixed about an axis, when you apply a force, it'll rotate, it'll not move in a straight line. Again, to give you a better example, imagine a simple tire. So tire, if there's no rotation whatsoever and you're applying a force, and if it's moving straight, that is transitional motion. That means there is no, it's not fixed about a point. It's just free to move about in any direction. So rigid body, when you apply a force which is not fixed to any point, which is free to move about, there you see that the motion that you see is transitional motion, whereas rotational motion occurs when the body is fixed about a point. Like in this case, you see this, the body is fixed about this point. It's pivoted, or it's pivoted about that particular point, and that is where you see that when you apply a force, rather than moving in a straight line, it starts to rotate about that particular fixed axis or fixed point. All right, we went all the way to the back. Let me just go back up. Where was that? All right, give me 1 second, guys. That was bad. Okay, so all the things you've already seen. Yeah, you went through all that. No, that's the session is done. Anyways, so this is rotational motion. You see this, that the wheel is rotating about an axis, and this is transitional motion where you don't see any rotation whatsoever. When you apply a force, the body moves in a straight line. Now, one of the concepts that you must know when you talk about a body being fixed about a point is called as torque. Now, why is torque so important? Because torque is something that you utilize in your day-to-day life. Everyday life, from the door hinges that you have to using a wrench to repair something, and all of that, you're using this concept called as torque. So what is torque? Torque is also known as moment of force. See, guys, like I told you, when a body is fixed about a point, when you apply a force, what happens is that you see rotational motion. So when the force is applied to a fixed end of a fixed point of a pivoted end, opposite side of the pivoted end. Obviously you can't apply a force over here, then there'll be no rotational motion. But when you apply a force at the opposite side of the pivoted end, so you have a wrench here which is basically held onto a nut, and that nut is basically the one that is basically the axis of rotation, or that is where it's pivoted at. So when you apply a force, what happens that you see rotational motion. That is what is called as torque. That motion that you see, that is what is called as torque. Now the formula is quite simple, guys. The formula for finding out torque is very simple. I'll come to that. Before that, guys, you have to understand two things. One is that when you apply a force, there is something called as line of action or line of force. So what does that mean is that this is the force. So the line of action would be basically a straight line from where the force is applied. Now this here is a pivoted end. So the distance from the pivoted end or the fixed point to where the force is being applied, the perpendicular distance, is one of the key factors that affects the torque of a body. Torque, or the moment of force applied on a body or acting on a body. And second is obviously the magnitude of force. The greater the force, the more is going to be the torque. So one is the magnitude of force. So greater the force, greater would be the torque as well. And secondly, the greater the distance, the more would be the torque as well. Now this is one of the best examples for that is nothing but your door. Now your door is hinged at a particular point. Have you ever noticed that the handle is always kept at the other end? It is not kept at the middle, or it's not kept to the right next to the hinge. It's kept at the end, at the other end. Why? Because the greater the distance that you have from the pivoted end, what happens is that the force that you have to apply is actually reducing. So there are two factors. Once again, the magnitude of force, and the second is the perpendicular distance between the line of action of force as well as the pivoted end. So these are the two things that you must remember. So distance of the action of line of the force from the axis of rotation. All right. So the formula, guys, is nothing but this. Tau, which is nothing but torque, is equal to F into L or F into D, where D represents the perpendicular distance, or L, whichever way you want to go it. Generally we go it as F into D, where D is nothing but the perpendicular distance, F is nothing but the magnitude of force, and tau is nothing but the torque. Simple. So yes, guys, once again, for all those who did not understand what is line of force or line of action of force, it's nothing but this. So when you have a wrench, you're applying a force in this direction. So the force that you're applying, whichever direction you're applying the force, the straight line drawn to that, when you extend that, that would be your action or line of action or line of action of force or line of force, whatever you want to call it, that is what it is. So in your examination, if you want, you can take this down, people, or take a screenshot of this one. What is torque? How is it defined? Torque is defined as the product of force and the perpendicular distance between the line of force and the pivoted end. Again, the formula is tau is equal to F into D, where F is nothing but the force and D is nothing but the perpendicular distance. Voila, that is the first concept done and dusted. Now, let's take another scenario. Imagine this, guys. Imagine that you want to open up a tap. Now, opening up a tap, when you open up a tap or of your the tap from the where water comes and stuff, yeah, the same tap, the old scale tap, old style tap. I'm not talking about the new one where you lift it up and all that. The simple tap that you have now where you have to rotate it. Now in those kind of cases, what you apply is equal and force equal. The magnitude of force is equal, but the force is acting in the opposite direction. Now that causes something called as couple. Now I'll come to couple in a couple of seconds right now. But before that, guys, let me just tell you this one more time. The further you are away from the pivoted end, the torque is going to be more. So you see this, when the force is applied right next to the pivoted end, the torque produces less. But when you apply the force at the further end, for as far away from the fixed point as possible, in that case the torque is going to be more. And also, guys, if the force is applied, if the line of force is exactly perpendicular to the pivoted end, in that case the torque is going to be less. But if it is not, then if it is exactly in line, so you have the pivoted end over here, so if it's exactly on that, if the line of force is acting exactly on the pivoted end, in that case the torque is going to be less. But if it's not, then it's going to be producing more torque. All right, so these are the things that you must remember. So again, guys, SI unit of torque is what? Newton meter. Why Newton meter? Because the SI unit of force is Newton, SI unit of distance is meter, so Newton meter is the SI unit of torque. Quite simple, right? And yeah, the CGS unit is dyne centimeter, because dyne is the CGS unit of force and centimeter is the CGS unit of distance. All right. Now, guys, one last thing, one more thing before we get into couple is this. See, you can produce either clockwise moment or you can produce anti-clockwise moment. Clockwise moment is considered to be negative torque. All right. Clockwise moment is considered to be negative torque. Anti-clockwise moment is considered to be positive torque. This is one more thing you must remember, because in your when you're solving numericals, sometimes you might have to figure out what type of moment is it. Is it clockwise or anti-clockwise? So in that case, you have to consider the sign as well. So if it's negative, you see it's negative sign, then it's clearly clockwise moment. If it is positive, then it's anti-clockwise moment. All right. So that is one more thing you must remember. Now, guys, couple. Now I already gave you a small hint about couple. Let's understand about that a little bit more. So here's the thing, guys. A single force cannot produce rotation if it is not hinged at the end. For example, imagine this pen. Now this pen is obviously not hinged at any point. It's not fixed at any point. So no matter where I apply the force, what do you see? You don't see rotational motion, but rather you see transitional motion. You don't see rotational motion. So in those kind of cases, we have to use a pair of forces to cause rotation. A pair of forces to cause the rotation. Like in the case of the tap, where you have a pair of forces acting, which is equal in magnitude but opposite in direction, and that type of force causes what is known as couple. And one of the best example for that is nothing but your steering wheel. Now the steering wheel is basically, it's fixed about an axis in the middle, right? You have a axis which is basically right in the middle, which basically is connected to the I'm not really sure how it really works, but yeah, you know that, right? So when you rotate it, what happens? The wheels also rotate. Yeah, so that's how it is. Now here's the thing, guys. So what do? You keep your hand in this direction, right? You keep it this way. So when you apply a force, what is happening is that one is going in clockwise direction, whereas the other is going in anti-clockwise direction. You apply the force, the magnitude of force is equal, but then the direction is different. One is clockwise, whereas the other is anti-clockwise. So in those kind of when you apply a force like that, people, that causes or that leads to what is called as moment of couple, or in simple words, couple. All right, a lot of examples you can think about that when you talk about opening up a lid of a cap. So when you open up a lid, like for example this one, when you open up a lid, you again apply a force equal in magnitude but opposite in direction. One is going in this direction, the other is going in this direction, clockwise and anti-clockwise. So in that way you're able to open it up. All right, so yes guys, that is one more thing you must remember. All right, so one is clockwise, this is clockwise, and this here would be anti-clockwise, right? So in that way you're able to open it up much more easily. This is what is called as couple or moment of couple. Now this the formula to calculate this is actually pretty much similar. For example, guys, let's say that this is the fixed point. Let's take this as O, let's say this is L and this is M. So you see this, guys, so the formula to calculate this is very simple. The couple the moment of couple is equal to either of the forces. Either you can take this force or you can take this force. That's totally up to you. Either of the forces into the perpendicular distance between the two forces. That is nothing but L. So it's nothing but F into LM. So whatever is the if you want to calculate the moment of couple, it's nothing but force, either of the two forces. Either you can take this one which is acting in clockwise direction, or the one that is acting in anti-clockwise or clockwise, whichever way you want. So again, here you see that the force into the perpendicular distance between them would give you the moment of couple. All right, so yes guys, that's pretty much it. All right, so yeah guys, you have clockwise moment, something like this one. Guys, I think I made a very big blunder. So yeah, in couple, I'm really sorry. In both would be clockwise or either anti-clockwise. Alright, I'm really sorry about that. I think yeah, I made a big blunder over there. I'm really sorry. So yeah, so once again, guys, just to correct that, so you have clockwise moment which acts in both the same direction. So direction, one is acting upwards, the other is acting downwards. That is what I meant by change in direction. Sorry about that. And then the perpendicular distance between them, whatever is the distance between the two, that would give you the moment of couple. For anti-clockwise, again, both in the same, one is going upwards, the force is acting upwards, the other is acting downwards, but again the formula remains the same, either of the two forces into the perpendicular distance between the two forces. All right, so here's the thing, guys. So again, let's say this is L, this is O, this is L, and this is M. So whatever is this distance, so again if you calculate it, the moment of force, that is a torque about this point, O, because of the force acting at M would be F into OM, so this would be F into OM. Then the moment of force acting about O because of the force acting at L would be F into LO. So when you add them both up to find out the total moment of couple, you will get it as F into L into F into L into LM. Alright, which is nothing but force into the perpendicular distance between the two forces. Alright. So yes guys, mathematically this is the formula, and once again I'm sorry about that. So both of them are acting clockwise or both of them are acting anti-clockwise. Sorry about that small little confusion. Alright, correcting that so that you guys don't get it wrong. Once again I'll repeat this. So in couple, either both the forces are acting in clockwise direction or both of them are acting in anti-clockwise direction, but the direction of force is different. One is acting upwards, the other is acting downwards. Alright, that is the only thing. And again guys, the formula is this: moment of couple is equal to what? Either of the two forces into the perpendicular distance between the two forces, and the SI unit remains the same, Newton meter, because force is Newton and distance is nothing but meter. So that's pretty much it. Alright guys. Now yeah guys, if you want to have such sessions and have more such sessions and more such sessions and more such sessions and have a lot of fun along with it, you can also enroll into the Vedantu Pro courses, where the link is given in the description. Alright, I'll tell you more about the courses, but before that guys, I should also tell you about Vedantu Improvement Promise. So here's the thing guys, Vedantu is giving you our word. We are giving you our word that your scores would definitely improve. Now if you feel like your scores are not improving, you can get the complete money back without any questions asked. The whole fee can be taken back without any questions asked if you feel like there is no improvement whatsoever. But also guys, there is one thing that we need from your side: attendance. You must attend the sessions. That is very, very important. And if you see that even after attending the sessions there's no improvement in your score, then you can take your money back, right guys? And that, my friends, is the Vedantu Improvement Promise. So we are that confident in our way of teaching that we'll definitely help you to improve your scores without a doubt. All right, so yeah guys, once again, more about the courses. So I'll just quickly go through that once again. So once again, I don't know why this is happening. So yeah, first of all guys, you have unlimited live session. You can attend how many of the live sessions you want. It's totally up to you guys, and all of these sessions will have quizzes, and yes, you'll have a lot of fun as well. And with these quizzes guys, you can also compete with your classmates and the rest of the world and see what chapters you're good at and what chapters you have to spend a little bit more time on. And with this guys, you have even the replay sessions that are there. So all the live sessions are recorded, and while watching the replay also you can take the quizzes and check out the leaderboards even while watching the replay. And that, my friends, is nothing but interactive replays. And yes, you can get all the notes. Every single thing that you see on the screen is downloadable. All the premium content for you guys in the form of PDF, so you can refer to it as many number of times you want. And with this, people, every session will not just have one teacher, but with the help of the master teacher, you'll also have the class teacher in order to clear every single doubt of yours. So whatever doubts you have, everything will be cleared inside the session itself without having to you need to carry it around in your head forever. You don't have to do that at all. And yes, you have some amazing tests and assignments as well. Time and again, these tests and assignments have proven to appear in your board exams as well. So yes guys, these tests and assignments are super duper helpful. And tons of micro courses, unlimited micro courses, where you have courses such as breathing exercises, you have courses for stress relieving, you have courses like Rocket Pro, you have courses like Vedic Math, all of that, KVPY, your NTSC, all of that would be covered for free. Everything in one bucket to cover up everything. So let me just show you how to enroll into the courses guys. Unfortunately, I've not opened up the tab. Let me just quickly open up a new tab, open up YouTube, and show you how to enroll into the courses as well. So let me just go to Vedantu 9th and 10th. First of all guys, subscribe in the meantime, don't forget. So what you have to do is very simple guys. Go to Vedantu, first of all subscribe to the channel, and yes, what you have to do is open up any of my videos that has been, so you obviously you're watching this video, so you have already opened it up. So let me just show you one of the videos that has come out very recently. Let me just show that. Yeah, so this is one of the videos that came out very recently. It was about the recent what is that crash that happened. So yeah, you can check that out as well. So what you have to do is go on show more and click on subscribe to Vedantu Pro right now. Once you click on it, people, this is what you're gonna get. The entire thing, you can see it over here. So you can choose which grade do you want. From 6th standard to 10th standard is what you have, and the other is Young Wonders, so you can go with that as well. So what you do is click on either of these, whichever syllabus you guys follow, ICC, Maharashtra, CBC, you can choose all of that over here. So let's say you're in ICC. Once you click on it, people, you can see that automatically 10% coupon code is applied to it, so you don't have to worry about the coupon code as well. So we have three types of courses, guys. We have Vedantu Lite, Vedantu Classic, and Vedantu Pro Plus. Let me tell you what are the disadvantages and advantages of each of these. Vedantu Lite has everything that you need. You have live interactive classes, test series, assignments, doubt solving inside the class, but there's no doubt solving outside the class. That is the difference, all right? Classic would have doubt solving outside the class also. You'll have the app, you'll have the access to the app. So from morning 8 o'clock till night 11 o'clock, you can ask how many ever doubts you want even after the session is done. Without the Pro Plus would have that as well as the personal mentor who will ensure that he's with you from the start till the end. He'll make sure that your scores are improving. He will take one-to-one sessions with you. He'll guide you throughout the entire process. Now again, each of these have their own advantages and disadvantages, so the price might also vary. So again guys, if you go for the 1 month program, that's 2,340 rupees. Again, that is after the 10% coupon code that has been already applied, and the year-long program would be 27,449 rupees. Now if you go for the Vedantu Classic, again 10% discount is automatically applied. The 1 month program is 2,970 rupees and the year-long program is 35,099. And again for Vedantu Pro Plus, where you get everything that you want and the personal mentor, you have 4,230 rupees per month, and the year-long program is 50,399 rupees. Now again guys, you might think that it's a lot of money, but think about it. If you just go with Vedantu Lite itself, that's 2,340 rupees. Let's take it as 2,400 rupees. Even if it is 2,400 rupees, you're getting all of the subjects. You're getting physics, chemistry, bio, math, English, social science. All 6 subjects are covered. And those 6 subjects, if you divide it by that 2,400 rupees, it is still going to be around 300-400 rupees. That's all. If you just take it as, if you take the actual price also, it'll be around 2,000, around 300-400 rupees per subject. Now a lot of you guys might be going outside for tuitions nearby your house where you're paying 300 rupees or 400 rupees per subject. All of that would be covered, and with that, like I told you, tons and ton more options would be there. So you can check out all the teachers who's going to be teaching you, all of the top teachers that you have. Vishek sir, obviously, Deanbandhu sir, Kritika ma'am, you can see a lot of teachers, and yes, every single subject would be covered. So you're completely safe in the hands. And like I told you guys, if you feel like there's no improvement, you can also take your money back. So that is also an option, right? So yeah guys, what more do you need? The guarantee that there will be no questions asked and your 100% of the money would be returned back. What more do you need, right? So all of that, all the details over here. And yes guys, that is a Vedantu improvement promise. You can check it out. The link is given in the description. No questions asked whatsoever. And yes, but yeah, like I told you, 75% attendance is mandatory and 75% of your tests and assignments are also mandatory. When you do that, obviously your scores would improve. No doubt about it, right? So that's the Vedantu Pro courses. And yes guys, these are the days that the batches are starting. So 10th of May is the batches already started for 9th as well as 10th. There's a new set of batches starting for 24th of May for 9th as well as 10th. So that's pretty soon. ICSE 24th of May, the batch is going to start. For 10th, it is about to start. I think it has already started 17th of May. For Maharashtra, it's going to be on 24th of May as well as for 9th and 10th. JEE, it's 10th of May, already one batch has started. 24th of May is the next set of batch. NEET as well. 10th of May, a batch has already started. 24th of May is the next set of batch that is going to be starting. Alright, so yeah guys, link is given in the description. Coupon code already applied. Done and done. Enjoy your life. And with that said, let's do some quiz questions as well. Let's try out some questions and see if we can solve it or not. So the first question, people, on your screens right now. The moment of force about a given axis depends on what? Only on the magnitude of force, only on perpendicular distance of the force from the axis. Neither of the forces are neither on the force nor on the perpendicular distance of force from the axis, or both on the force and its perpendicular distance from the axis. The moment of force. Remember guys, tell me the answer in 5, 4, 3, 2, 1. Let's go. Moment of force is nothing but torque. Now the formula for torque is what? Tau is equal to what? F into D. So F is nothing but the force, the magnitude of force, and D is nothing but the perpendicular distance from the axis of rotation. So which option do you think is the right answer? Option number D. That's all. Force as well as perpendicular distance from the axis. Both of these are the factors. Next one. A body is pivoted at a point P. A force of 20 Newton is applied at a distance of 40 centimeters from the pivot. Calculate the moment of force above the pivot. You have to calculate what is a torque over here again. Moment of force, nothing but torque. So again, options are 3 Newton meter, 6 Newton meter, 8 Newton meter, or 10 Newton meter. Let's try to solve this. Quite simple guys. First of all, write down what is given to you guys. First of all, the force is given as 20 Newton. The distance is given as 40 centimeter. Now here's the thing guys. The SI unit of torque is Newton meter, not Newton centimeter. So convert this to meters divided by 100. How much is that? 0.4 meters. Now put it in the equation. Tau is equal to what? F into d. F is 20 into 0.4. So 8 Newton meter would be the answer. As simple as that. How hard was that? How hard was that? Next question. An iron door of a building is 3 meters broad. It can be opened by a force of 100 normally at the middle of the door. Calculate the torque needed to open the door. Calculate the least force at and its point of application to open the door. The least force and its point of application to open the door. Alright. So here's the thing, guys. Imagine a door. Let me write on the question first. Let me just draw it out for you guys. So here's the thing. This door is about 3 meters broad. Alright. You can know if you apply a force right in the middle. Alright. You can open the door easily. So first of all, calculate the torque needed to open the door when you apply the force in the middle. So how will you calculate that for the first one? So again, half the distance is what? Half the distance is 1.5 meters. So calculate that then. So again, torque is equal to force into perpendicular distance. So force is how much? You're applying a force of 100 Newton and D is nothing but 1.5. So how much is that? It's 150 Newton meter. That is the force you have to apply generally when you apply the force in the middle of the door. Now the second part of the question is the least force and its point. Where can you get the least amount of force? When you apply the force exactly at the furthest end. So this is basically the fixed end. So when you apply the force at the extreme end, so basically the distance in this case would be 3 meters itself. Calculate what is the force. Calculate what is the force. So in this case, people, again, the torque is 150 Newton itself. Let's say the torque is 150 Newton meter itself. Wait, calculate the least force and its application of force. Calculate the force, the least force. Then calculate the least force and its point of application. All right. Okay, let's try to do this way now. So force. Into 3. So F is equal to what? 150 divided by 3. 50. So I think it should be 50 Newton. If I'm not wrong, 150 Newton meter. Yes, that is the right answer. 50 Newton and 150 Newton meter. I know, I'm a genius. I know. So yeah, people, that's all. So all you have to do is basically you're assuming that the torque is the same, 150 Newton meter itself, and your the distance. So where will you get the least amount of force? The least amount of force has to be applied when the force is applied at the extreme end. The further away from the point of application, or the point of the axis of rotation, the lesser the force you have to apply. So yeah. So yes, people, let's do the fourth question as well. Here's the fourth question. In a figure, a roller of diameter 0.4 meters is raised by a pavement of XY by forces F1 and F2, each of magnitude 10 Newton. So both of these are what? 10 Newton forces. Alright, 10 Newton is the magnitude of both these forces. Compare the torques produced by both these forces. Alright, now here's the thing, guys. So this is the point of rotation, because it's about a pavement, it's rotating about a pavement. That is a pivot, or that is a axis of rotation. Now, what is the perpendicular distance for F1? The perpendicular distance is nothing but the diameter. So that is nothing but 0.4 meters. So for F1, find out the torque. Tau 1 is equal to what? F1 into D1. So where F1 is equal to 10 into D1 is 0.4, which is nothing but 4 Newton meter. Now for Tau 2, which is nothing but this force F2, the perpendicular distance is what? It's nothing but 0.2 meters, because again, this is the axis of rotation, this is the line of action of rotation, this is the line of action of force, line of force. So when you calculate that, what will you get? F2 into D2. F2 is again 10, D2 is 0.2. So what will you get? You'll get is 2 Newton meter. So the answer to this question, guys, is nothing but you're supposed to find out what is the ratio. So that's nothing but 4 by 2, which is nothing but 2:1. So the answer to this question, guys, is option B, which is nothing but 2:1. That's all. Alright. So that is your last question, people. With that said, this is your homework for today. A steering wheel of diameter 0.5 meters is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Calculate the moment of force applied. Alright. Let me know what is the answer in the comment section. That's it for today. Thanks a lot for joining. Catch you guys in the next one. Until the next time we meet, do not forget to like, share, and subscribe. I'll see you guys soon. Do not forget to take the Vedantu improvement promise as well. See you soon. Take care. Enjoy your life. Until then, bye bye.